Hi everyone, today I am going to do some level 2 and level 3 MCQs from the chapter of current electricity. Okay, so without wasting time, let's start. So the question number 97 in level 2 in our material. So this question is given, right? This is a battery of EMF 2 volt. No internal resistance is mentioned. Here two resistors 1 ohm 1 ohm is mentioned. Here is ammeter, here is voltmeter. You have to find the reading of the voltmeter. As I told you, voltmeter will find potential difference between its terminals. Okay. So voltmeter will always measure the potential difference between its terminals. And those 2 points are same as these 2 points, isn't it? Right? But this is a conductor, this is a conductor. So these points will be same potential. These points will be same potential. So to find potential difference here, we need to find potential difference here. Now, they have not mentioned anything about this ammeter and voltmeter, meaning they have not mentioned their resistances. So if they don't give the resistances, we must assume they are ideal ammeter and ideal voltmeter. And as I told in the class, ideal ammeter has zero resistance and ideal voltmeter has infinite resistance. Zero resistance means it will be acting like a wire without any resistance, which we say short circuit, and infinite resistance means it will act like open circuit. So your circuit will be something like this now. So this ammeter can be replaced by zero resistance wire and voltmeter will be open circuit. So now current will flow this way, isn't it? Now though current is flowing, in this part there is no resistance, so voltage here will be what? I into R of this part, right? If you want potential difference between 2 points with some resistance and current I is flowing, then potential difference between these 2 points is I into R. But this part of the wire has zero resistance, so I into 0, which is 0. So voltmeter reading is 0, that is the answer. Okay. What if they asked ammeter's reading? Ammeter was here. So ammeter will measure current. So ammeter's reading will be I equals to EMF divided by total resistance. Total resistance is 1 ohm and 1 ohm in series will be 2 ohm. So the current will be 1 ampere. Okay. This was not asked. So this is the answer. So the next question 103. So there is a cell of EMF E and internal resistance R. It is connected to an external resistance capital R. The potential difference is given as capital V, which is also the potential difference here, right? Because these 2 points are same and these 2 points are same. So we have to find internal resistance in terms of EMF, potential difference across the cell or across the external resistance, and capital R, which is external resistance. So how to find small r in terms of these three? Well, we know that terminal voltage is E minus I into small r, because current will go this way from plus to minus, right? So when current starts from positive terminal and goes to negative terminal outside the circuit, we write terminal voltage as E minus IR. So now I can write this as V E minus I can be written as V by R from Ohm's law, because V must be I into R. So now if you simplify, you will get the answer. So if I bring this side, VR by capital R will be equal to E minus V. Then you divide by V both the sides. Then you cross multiply with capital R. Okay. So that would be your internal resistance, which can be written E by V minus 1 into R. Okay. Now in question number 105, they have given this circuit with resistances, and here they have given current is 1 ampere. Not here, remember, here. We have to find EMF. Okay. Now if current here was given, it would be very simple, right? If current here was given, then I will just find the equivalent resistance of this circuit, equivalent resistance, and I will replace the whole network with this single resistance. Now I can easily find EMF because I will be what? EMF by total resistance, which is R equivalent. So EMF would be I into R equivalent, isn't it? But the problem here is we don't know current here. So how to find current here? Let us try to understand. So you can see current in this branch is given 1 ampere. That means voltage here, if I call this A and B, potential difference between A and B will be I into R. So 2 volt, isn't it? I into R. Now same voltage will be here also, and I can replace these two resistors by a single resistor of resistance 2 ohm, because 1 ohm and 1 ohm are in series, so 2 ohm. Now voltage here is 2 volt, so voltage here is also 2 volt, right? So here also voltage is 2 volt, and if voltage is 2 volt, resistance is 2 ohm, then current here will be V by R, Ohm's law for this resistor. Voltage is 2 volt, resistance is 2 ohm, so current is 1 ampere. So current here we found is 1 ampere. That means if this is 1 ampere, this is 1 ampere, that means here is 1 ampere, here is 1 ampere, right? 1 ampere, 1 ampere. So here current must be 2 ampere, isn't it? Because this 2 ampere will divide here 1 ampere, 1 ampere. And this 2 ohm and 2 ohm are in parallel. So in parallel, what is the equivalent resistance? 1 by Rp, 1 by 2 plus 1 by 2, which will be 1. Reciprocal will be also 1. So this whole circuit can be replaced by 1 ohm resistance, right? 1 ohm resistance. Also you can see 2 ohm and this 1 ohm are in series, right? Same current will flow. So these two can be replaced by equivalent resistance, which will be 2 plus 1, 3 ohm. Now 2 ampere current is flowing like this. So voltage here will be what? I into R. I is 2, R is 3. So 2 into 3, 6 volt. Now if voltage here is 6 volt, voltage here also will be 6 volt, right? So voltage here is also 6 volt. Now if voltage here is 6 volt, resistance is 6 ohm, current will be what? Current is voltage by resistance. So voltage here is 6, resistance here is also 6 numerically. So current here will be what? 1 ampere. So current here is 2, current here is 1, so current here must be how much? 3 ampere, isn't it? 2 ampere went here, 1 ampere went here. So after understanding this, I can replace these currents now. Now, what was the resistance of this? 6 ohm, right? Now, this 6 ohm and this 3 ohm, you can see, are in parallel. So equivalent resistance will be R1, R2 by R1 plus R2, 18 by 9, 2 ohm. So this whole thing can be replaced by 2 ohm, right? So here I can put 2 ohm. Now this 2 ohm and this 2 ohm are in series. So this whole thing can be replaced by 4 ohm, isn't it? So now we know the current here, we know the equivalent resistance. So basically we have converted that circuit into this circuit, and we know current here and we know resistance here. So EMF will be I into R equivalent, which is 3 into 4, 12 volt. Okay. If there was some internal resistance, then you just add internal resistance also. What is there, right? Now in the next question 106, they have given you some resistors and cell, and they want current in 3 ohm. Now this circuit looks slightly different because they have given all this as grounding, and here open circuit you may feel, but actually it is not open because all these are connected to ground, means you can connect this thing directly to this ground. So it's the same thing because potential of all these point is 0 volt, right? So now there are many ways to find current in 3 ohm. So let me just try one method and then I will see if another method we will do. Okay, so method 1, what we can do is we can first find current distribution. So let's say current here is I, that I will divide here I1 and that I will divide here I2. So basically we are supposed to find I2, isn't it, current in 3 ohm. So now if I redraw this circuit, this tree and this tree are in series, so equivalent will be 6 ohm. So this will be 6, this will be 2, this will be 2, this is 10 volt. Current I was going and that I divided here I1 and I2. Correct? Now let us try to find the main current. So this is 10 volt. These 2 and these 2 are in parallel. So in parallel, what is the equivalent? 6 into 2, 6 plus 2, 12 by 8. 4 3s are 4 2s are, right? So this can be replaced by this circuit, isn't it? 3 by 2, 1.5, and here 2. So now the current starting from the battery, the main current, will be equals to EMF 10 volt divided by total resistance 3.5, which is 100 by 35, 5 7s are 5 2s are, so 20 by 7 amperes. So that is the main current. Now once you know the main current, you can find current here by using branch rule. So current in 6 ohm resistor will be resistance of opposite branch divided by total resistance into the main current. Main current means current coming from here, which divides. So main current is I. So 2 by 8 into 20 by 7. 4 2s are, 4 5s are, isn't it? 2 2 cancel, so answer should be 5 by 7 amperes. Okay. If you don't remember this branch rule, then you can see these 2 points have some potential difference, and that will be same as potential difference between these 2 points, because this resistor and this resistor are in parallel. So here voltage and here voltage should be same. Voltage here will be what? I into R. R is 2. Voltage here should be I into R. I2 into 6. So 2 3s are 6. So from here I1 will be 3 times I2. Then we know total current I is I1 plus I2. Right? Total current how much was coming? 20 by 7. I1 is 3I2. So if you substitute 3I2, 4I2, then 4 5s are 20. So I2 will be 5 by 7 ampere. Okay. So another method to find this is to understand that all these points will be at same potential, isn't it? So if I call this point as 0 volt, this will be also 0 volt, this will be also 0 volt, right? But here potential difference is how much? 10 volt. That means this point is higher potential than this point by 10 volt. Difference is 10 volt, right? So if this is 0 volt, this should be plus 10 volt, isn't it? And this point, we don't know the potential. Let us assume this point is V volt. So this is V volts. Okay. So they may ask you find the potential of this point, this point. So in that case, this method will be very useful. So you can see that current I is dividing between I1 and I2. So I1 plus I2, isn't it? Also you can see that this 3 ohm and this 3 ohm are in series, so you can replace both of them by 6 ohm resistance, right? Circuit will remain same only, equivalent resistance means what? If you replace those two resistors by equivalent, the circuit should remain same. So if I2 was flowing before, now also I2 should flow. Now this I is, remember, current in 2 ohm, isn't it? This I is going like this. So to find current in this 2 ohm, you can use Ohm's law for this 2 ohm. And if current is going this way, this point is higher potential than this point. And what is current from Ohm's law? Potential difference by resistance. So what is potential difference here? 10 minus V divided by resistance. Clear? So this is the potential difference, 10 minus V divided by resistance, equals to current here can also be written according to Ohm's law. So current in this 2 ohm will be potential difference between the two ends of this resistor, which is V minus 0 divided by 2 ohm, plus here if this is V, this point is also V, because this is zero resistance wire. So potential should be same. So what is the potential difference here? V minus 0, resistance is 6. Now let us try to solve this. So 10 minus V by 2 is equals to V by 2 plus V by 6. So this will give me 10 minus V by 2 equal to 6, 3V plus V. So this will give you 2 3s are 6. Then if you cross multiply, you will get 30 minus 3V is equals to 4V. Then 3V will go that side, so 30 will be 7V. So V will be 30 by 7 volt. So we found potential at this point. Remember, our job was to find current here, because 3 ohm and 3 ohm was sitting here, right? So this current we want. So now I2 can be found from this relation. So I2 from Ohm's law is potential difference here, which is V divided by this resistance 6, which is 30 divided by 6 divided by 7, right? 30 by 7 divided by 6. So this is V, right? 30 by 7. Then I have to divide by the resistance, which is 6. 6 5s are 30. Same answer we got, right? Another method that you can use is Kirchhoff's voltage law, okay? And Kirchhoff's current law, obviously. So how to find current here using Kirchhoff's voltage law? And when you get too much confused with the circuit, then it is always better to use Kirchhoff's voltage law, okay, for safety. So in Kirchhoff's voltage law, what we do first, we have to assign current. So let's say current here is I, and that goes here, a part of that goes here, I dash, remaining will go here, remaining how much? I minus I dash. So this is how we first distribute current using Kirchhoff's current law. So if 10 ampere is coming, 2 ampere is going here, 8 ampere should go here, right? Okay. Now we will use KVL. So we will use KVL in first A, B, C, D loop. A, B, C, D loop. Back to A. So along the current drop, so minus I into R. Along the current here also drop, minus I dash into 2. And here minus 2 plus for battery means rise. So rise is plus EMF is 10 volt. This is equation 1. Then you can use in this loop, okay? So C, D already I used here, so E, F let me write. So C, E, F, D, C. So in this loop if I use, here I dash is going, right? Because I dash will flow in this branch. So along the current drop minus I dash into 3. Along the current drop minus I dash into 3. Here I am going against the current, so rise plus I minus I dash into 2. Once you reach the starting point, algebraic sum should be 0. So this is your equation 1 and this is your equation 2. You can solve these two equations and you will get the same answer. Let me try to show you fast. So minus 3i dash, minus 3i dash, minus 6i dash, in here minus 2i dash. So minus 8i dash plus 2i equal to 0. So this will go that side. So 2i will be 8i dash. So from here I will be what? 4i dash. Now we will substitute this I here. Now let me first simplify equation 1. So minus 2i will be minus 4i. Then minus minus plus 2i dash. That is plus 10 equal to 0. Now what is I? 4i dash. So this will be minus 16i dash plus 2i dash plus 10 equal to 0. Minus 6i dash plus 2i dash minus 14i dash is equal to 10 will go that side, minus 10, minus minus cancel, I dash will be 2 5s are 2 7s. So 10 by 14, which is 5 by 7. So I gave you 3 methods to solve the same question. So please go through it once more and just check that everything is clear. And whichever one you feel you are comfortable, you use it. Okay. Now in question number 110, they have given two identical cells. Now you know that every cell has two things, EMF and internal resistance. So if the cells are identical, it means the EMFs and internal resistances are same. So first they connected the cells in series, okay, and when they connected external resistance 2 ohm, some current is flowing. Then they told when the same cells are connected in parallel and then the combination of the cells is connected to an external resistance which is again 2 ohm, they found the same current is flowing. So this current and this current are given to be same. Value is not given but currents are same. So they are asking what is the internal resistance. Now you know when cells are in series, what is the equivalent EMF? E1 plus E2 if they are connected this way. Right, both the cells are sending current in the same direction, right? This will send current this way, this will also send current this way. So they are helping each other. So the total EMF of these two in case of series will be E equivalent will be 2E and R equivalent will be 2R, R1 plus R2. Now in parallel, what will be your E equivalent? E1 R2 plus E2 R1 by R1 plus R2. But they said it is identical, so it will be ER plus ER by R plus R, which is 2ER by 2R, 2R, 2R cancel E. So in parallel, equivalent EMF is E. And what is the equivalent internal resistance? R by 2, because formula for parallel is 1 by R plus 1 by R, 2 by R, then ulta will be R by 2. So the current here in series, what will be the answer? E equivalent divided by R external plus R equivalent. This is the Ohm's law applied to circuit with single cell, right? So once you convert these two into one cell, you can use this formula. And how much was E equivalent in series? 2E. External resistance is 2. Internal resistance is 2R. Right? Then in parallel, what will be the current here? This parallel current. So here equivalent EMF is E itself, right? E and E in parallel will give you E itself, remember. Divided by external resistance is same. Equivalent internal resistance is R by 2. Okay. So this will be E and here LCM 2, 2R plus R. 2 will go up, 2E by 2R plus small r. And what was the external resistance? 2 ohms. So this will be 4 plus R. Right. Now it was given in the question that IS equals to IP. The current here and here are same. So 2 EMF by 2 plus 2R must be same as 2 EMF by 4 plus R. This 2E cancel, cross multiply, you will get 4 plus R equal to 2 plus 2R. 2 will come this side, R will go that side, so R will come, this R will go there, 2R minus R is R, this 2 will come here, 4 minus 2 is 2. So internal resistance is 2 ohm, right? So now let us see the next question, 116. So they told there are 100 cells, so this is the total number of cells, each of EMF 5 volt and internal resistance 1 ohm. These 100 cells are connected to an external resistance which is 25 ohm. Now there are rows, okay, these cells are arranged in rows and each row has equal number of cells. We have to find the number of rows. So let's say the cells are connected something like this. Okay, so there are n cells in one row. So this is one row. So like that there are many rows. So let's say m rows are there. How many rows? M rows. And each row has n cells, n cells, n cells, n cells. And this whole combination is connected to external resistance which is given to be 25 ohm. Now they must mention here that whatever current flows here, either they should give the current or they should say this current is max. Okay, either these two they have to mention. Either current should be given the value of current or maximum current is flowing, that has to be mentioned. Why? Well, if you replace this whole thing by one cell, how it will look? Each cell is same EMF, so it will be E N times will be NE. So this row will be NE EMF. Internal resistance will be smaller n times will be n into smaller. Same thing will happen here. NE. So like that m rows are there. Now just now we learned that if E and E EMF are in parallel, equivalent is also E. So if NE are in parallel, equivalent EMF will be NE itself. Okay. And internal resistance, if R and R are in parallel, we get R by 2. Here NR is in parallel how many times? M times. So it will be NR by M. Right? If it was R by 2. R by 3. R M times R by M. But this is not R, this is NR. So NR by M. So this is the equivalent EMF, this is the equivalent internal resistance. Okay. Now if this current was given, we can write I is equals to E equivalent by external resistance plus R equivalent, right? So E equivalent would be NE. So N we don't know. Capital R plus R equivalent is what? NR by M. Now what are the values given here? EMF is given 5 volt. So it will be N into 5. Capital R is given 25 plus number of cells in a row that they have not given. Internal resistance they have given 1 divided by number of rows they have not given. So you see, if you look at this equation carefully, you can see that N, M are unknowns, but current is also unknown. So 3 unknowns are there. And we have one equation here. One more equation will come from here because 100 cells they have given. So what will be total number of cells? Okay. They have given there are n cells in one row. And how many rows are there? M. So imagine there were 6 boys in a bench. And there are 4 benches. So 6 boys in one bench and there are 4 benches. So total number of boys will be 6 into 4, 24. So here total number of cells will be what? N into M. And that was given 100. So N into M must be 100. So one equation is there, right? And this will give you one more equation. But capital I is not given. So that's why I told if capital I was given, then we will substitute here and we will get one equation between N and M. And one more equation we have already here. So those two equations we can solve. So this question is incomplete, but usually what they will say is the current flowing here is maximum. And if that happens, the power consumed here will be also maximum, right? And for that to happen, for power consumed to be maximum, what was the condition according to maximum power transfer theorem? The internal resistance should be equal to external resistance. So here internal resistance is NR by M. External resistance is capital R, right? Only one external resistance. So this is N, small r was given 1 ohm and capital R is given 25. So this will give you N equals to M into 25. Now we will substitute this N in this equation. Okay, so N is M into 25, substitute here M into 25. So you will get M square into 25 equals to 100. So M square will be 4, 25 4s are 100, M will be 2, square root of 4. Minus solution is not acceptable, right here. So how many rows are there? 2. Now let us see question number 170. They have given two cells A and B. A has EMF 2E, internal resistance 4R. B has EMF E, internal resistance R. They told the negative terminal of A is connected to positive terminal of B. And this forms a battery now. Okay. That battery is now connected to an external resistance capital R. Now the important thing they told is the potential difference across cell A, meaning here the terminal voltage or terminal potential difference across this cell is 0. So if this is given, we have to find this external resistance in terms of internal resistance R. Okay. Now to find the terminal voltage here, first we should know the current. And you know that both the batteries are helping each other because this will send current this way, this will also send current this way. So current I will flow this way, right? That I will be what? Total EMF. Now they are in series, so total EMF is 2E plus E. And total resistance is R plus internal 4R plus R, right? Everything here is in series, remember. So that will be 3E divided by R plus 5R. Okay. Now voltage for a cell, terminal voltage formula is what? E minus I into R. But that is for first cell. So we have to write EMF of first cell, internal resistance of first cell. I will be obviously same in series. So now this voltage they told should be 0. EMF of the first cell is 2E minus I into R, internal for the first cell is 4R. Bring it this side, you will get I 4R is equals to 2E. So this 4 and 2 will cancel. So I into 2R will be E. Now I we found is 3E divided by R plus 5R into 2R equals to E. I just substituted this I. Okay. This E and this E cancels. Cross multiply. First multiply 3 into 2R, 6R. Then cross multiply R plus 5R. Then bring this 5R this side. You will get 1 into small r. So capital R will be small r. Right? Now let us do the next question. Question number 153. So here A, B, C are 3 voltmeters. and they are not ideal voltmeters because they have finite resistance. It is given that their resistance is R, 1.5 R and 3 R. Okay, so they are not ideal. Ideal voltmeters has infinite resistance, isn't it? Now when some potential difference is applied between X and Y, so here if you connect some battery, let's say, there will be some potential difference between this X and Y. So they are asking the voltmeter readings, VA, VB, VC. Now voltmeter reading means what I told. If there is a voltmeter and you want to know the reading of the voltmeter, then it is always the potential difference between this point and this point. Okay, so if I call this point X, already it is mentioned, let me call this point as Z. So VA means voltage between X and Z. Now what about these two? These two are in parallel, so voltage across these two will be obviously same. So VB will be equal to VC. By the way, we have to relate. We have to find the relation between the voltmeter readings shown by A, B, C. One relation already we found, that voltage here and here must be same because they are in parallel. Now what about voltage between these 2 points and between these 2 points? What about that? Well, for that, let us replace these two by equivalent resistance, because you can see these two are in parallel. So equivalent will be R1 R2 by R1 plus R2. R1 is 1.5 R, R2 is 3 R divided by 1.5 R plus R. That will be 1.5 into 3 is 4.5 R into R square. 1.5 R plus R. Well, no, this is not R, this is 3 R, right? So 1.5 R plus 3 R will be again 4.5 R. That will give you R. That means if this resistance is R between X and Z, which is the voltmeter reading of VA of this device, then between Z and Y, what is the equivalent resistance? R itself we have found. Now no matter what battery you connect, I don't care, in series current will be same. So if current is same, resistance is same, automatically from Ohm's law, voltage here VA will be equal to voltage between Y and Z, which is voltage between either B or C. So this voltage must be equal to this voltage because this resistance came out to be R, which is same as this. So the numbers were given in such a way that the equivalent resistance of this is also R. So therefore I is same in series, so this voltage is same as this voltage. So what is the final relation? VA equal to VB equal to VC. Okay. So now we will do the next question, question number 154, where we have a circuit with two different cells. EMF of this is 18 volt, EMF of this is 12 volt, internal resistance are 2 and 1. Now here they have connected a voltmeter and they want you to find reading of voltmeter. Now here they have not given you resistance of voltmeter, so you have to consider this voltmeter as ideal voltmeter, and if it is ideal, resistance of this will be infinity, and if it is infinity, you can consider this as open circuit. So the equivalent circuit will look like this. Okay, I am showing the internal resistance so that you don't miss it. Okay, here they have not shown the circuit symbol for internal resistance. I have shown here so that you don't forget it by mistake. Now remember, I need to find voltage here, and that voltage is nothing but terminal voltage across this cell, or you can say across this cell also. Both way same answer must come. Now these two cells, remember, will carry current either this way or this way, right? Because current cannot go there. So either current will go here or here, which means same current flows through different parts of the circuit means what? It is in series. So in series, what is the equivalent EMF? Either E1 plus E2 or E1 minus E2. Here they are helping each other or opposing each other. This battery is sending current here. This battery is sending current opposite. So they are opposing each other. So E1 minus E2. Bigger one is 18. So 18 minus 12, which is 6 volt. Okay. And since this is bigger, current will follow according to this cell. So same current will flow everywhere like this. Okay. Now, what will be the total resistance of this circuit? Remember, there are no external resistance mentioned. So this is 2 ohm, this is 1 ohm. So the resistance is 3 ohm. So what will be current now? Total EMF is 6, total resistance is 3, so 2 ampere. Now once you know current, to find voltage across this cell, what is the formula for voltage across a cell? E minus IR. What is EMF of this cell? 18. Current in this circuit is 2. Internal resistance is 2. So 2 into 2, 4. 18 minus 4, 14 volt. So that is the voltage across this point and this point, which is same as between these 2 points. And that is the reading of the voltmeter. So that would be the answer. What if I use this cell? Well, I can use this cell also. Here also I can find the terminal voltage, and that voltage, if I write V dash, what it will be? E plus IR. Why plus? Because see, for this cell current is coming out of positive terminal, so we write minus IR. But for this cell current is entering the plus terminal. So actually this cell is getting charged by this cell. So for this cell, during charging we write plus IR. Of course E and small r, they are different between these two cells. So what is EMF of this cell now? 12. Current is 2. Internal resistance of this is 1. So 12 plus 2 is 14. So either you can find terminal voltage here or here. Same answer you are going to get. And that will be the reading of this voltmeter, right? Now let's say this voltmeter was not ideal. Let's say the resistance of the voltmeter is given to be, let's take it 5 ohm. Okay, just a separate question. Then what will be the reading of the voltmeter? Let us try to see. So now you cannot say current coming here will not go there, because now this has a finite resistance, so some current will go there also. So now to find voltage between these 2 points, what you can do? You can replace these 2 cells by one cell. E equivalent, R equivalent, and here is your voltmeter. Remember, resistance of voltmeter is 5 ohm. So if you want, you can replace it by a resistor. So to find voltage between these 2 points, I need to first find equivalent EMF. Now these two are in parallel because current will go this way and this current will divide here. So this current and this current are not going to be same. So now we cannot say these two are in series like previously. So now we have to consider these two cells as parallel, and E equivalent in parallel, what is the formula? E1 R2 plus E2 R1 by R1 plus R2. Okay, whichever you want, you can call E1 R1, E2 R2. So this will be 18 plus 24 by 3. This will be 242 by 3. So that will be the equivalent EMF. And this will come out as a nice number, right? 3 1s are 3, 1 carry, 3 4s are 12. So 14 volt. And what will be R equivalent? 2 into 1 by 2 plus 1. So 2 by 3 ohm. So now you can find the current in this circuit, I. So what will be that I now? E equivalent by R external plus R equivalent. E equivalent is 14, R external is the voltmeters resistance 5, and internal resistance is 2 by 3. So some current will flow, right? This much current will flow. Now to find voltage between A and B, you can either write I into R of the voltmeter, right? Ohm's law for this, or you can also write voltage between A and B as voltage across this cell. Remember, current is coming out of the positive terminal. So E equivalent minus I into R equivalent. Now I request all the students to actually substitute this current here. Resistance of voltmeter is 5, no? So calculate this, check what is the voltage between A and B. Same way, check this also. Okay, you will get the same value. One interesting thing you note, if this was infinity, like ideal voltmeter, then this part will be open, I told you. So then this current will not flow this side. So this I here will be 0. Then what will be voltage across A and B? E equivalent. And this is, if you check, 14 volt, which is same as the previous one. Now let's see the next question, question number 155. So here is a circuit given with resistors and EMF of the cells, and here current is given 2 ampere, here 1 ampere up, 3 ampere down. We have to find potential difference between G and H. Now whenever such questions come where they want potential of one point minus potential of another point, then always use rise and drop method, meaning you start from this point and reach up to this point, and as you go, wherever there is potential drop, subtract the voltage, and wherever there is potential rise, add the voltage, obviously, right? So let's try to see. But before that, we need, here though we know current, and this 2 ampere will come here, 2 ampere, 2 ampere, 2 ampere, right? So here also 2 ampere. Now here how much it will be? Now here 1 ampere, here 3 ampere, so this must be 4 ampere, isn't it? According to Kirchhoff's current law. Let me put a circle because this part I have found, okay? So this current divides here and here, so this must be 4 ampere. Now here you look carefully, this is 4 ampere, this is 2 ampere, but here 4 ampere, so 2 ampere must come this way, isn't it? So this is also I have found, so I am putting a circle here. Only then this 2 ampere and this 2 ampere will give here 4 ampere, obviously. So now because I know here current and here also, I can use rise and drop method between G and H. So G to H, let's start. So I'll start from this point, potential is Vg. Now as I go this way, I am going along the current. Current flows from higher potential to lower potential. So there is a drop in potential. Minus I need to write. What is the voltage drop? I into R. 2 into 4. Then here I go, nothing is changing. Now here battery, minus 2 plus, there is a rise. So plus for battery, what is the EMF? 3 volt. Don't write I into R, okay, for battery. Then in this resistor also I am moving along the current. So along the current means current flows from plus to minus. Again drop. Minus I into R for this will be what? 2 into 2. Then I reach this point. Now don't go there because we need potential difference between G and H. So come here. Now be careful, as you come down, current is going this way. So this is plus, this is minus. But I am coming this way, right? So when I come this way, I am going from minus to plus. So it is rise. So plus I into R. What is I? 2. What is R? 1. So 2 into 1. Once you reach this point, you will reach the potential of H. So why this works is very simple. Suppose you started from here with rupees 10. Then you went down, your money decreased by 2 rupees. Okay, then it again increased, again decreased. So that will be your final money, isn't it? Final money. So wherever it decreases, subtract, wherever it increases, add. So you started with potential at G, then here it was decrease in voltage, increase in voltage, again decrease in voltage, and again increase because minus 2 plus. So that will be 8 plus 3 minus 4 plus 2 equal to VH. So this will be how much? Minus 8 plus 3 minus 5 minus 5. This 2 will give minus 2 minus 7. So Vg minus Vh will be 7 volt, right? Number 156, they have given you this circuit with 2 ohm, 4 ohm resistance, here 2 ohm resistance. Here there is a switch and this is grounding, okay? And this point is connected to 20 volt potential and this point is connected to 5 volt potential. These are potential, okay, not potential difference, potential of this point. Now, when the switch is closed, they are asking how much current will flow through the switch. Here they want the current. So the best way to do this is, let us assume this junction here is at potential V volt. Okay, this is ground, so this will be 0 volt. Now let's say current from here is I1, current from here is I2 and current here is I3. Let's assume. Then you know that this is entering, this is entering. So I1 plus I2 must be equal to current leaving. Right? Now you apply Ohm's law to find this current. What Ohm's law says? Current through a resistor is potential difference across its ends divided by resistance. So current here is potential difference here, that is 20 minus this potential which we don't know. So 20 minus V is the potential difference between this and this divided by resistance. What about this current? Potential difference between this and this, which is 5 minus potential of this we don't know, divided by resistance of this, equals to this current, and this current is potential of this minus potential of this. Potential of this we don't know. Potential of this is ground, meaning 0 volt, divided by resistance of this. So now we can easily solve. So this will be 20 minus V by 2 plus 5 minus V by 4 equals to V by 2. Now you can take LCM and solve, or you can multiply both sides by 4. So 4 into 20 minus V by 2. If you multiply with 4, this will be 5 minus V. Multiply with 4. 4 into V by 2. So this 2 and this 2 will give 2. This 2 and 4 will cancel 2. So 2 into 20, 40 minus 2V plus 5 minus V, 2V. Minus 2V minus V minus 3V will go that side, you will get 5V. 40 plus 5 will give 45. So from here V will come how much? 9 volts. So potential of this point is 9 volt. Now this current they asked, I3. So that will be this, right? This is your I3. So V minus 0 by 2. V is 9 minus 0 by 2, this is 4.5 amperes. Okay.